recording. And let's start out with a few minutes of this.
Minus 21.
Okay.
13. 8. Minus 8. Minus 6. Minus 11.
Your speed is getting better.
Minus 30. 6. 6.
That's enough. You're doing good there. All right. For the last session or two, we've been covering 3 different types of factoring.
Tell me about it.
Let's go back and do some more. Let's talk about greatest common factor. And then the second one we have is factoring quadratics. Let's call it that. I'm not sure that's the right terminology. And the third one we have is difference of perfect squares. Greatest common factor. Factor that.
So wouldn't you plus the 8?
Hold on. Remember what we're looking for when we're looking for a greatest common factor. We're looking for the largest term that divides evenly into both of these two terms that are being added together.
And that would be 2.
There you go. And what's left over? In other words, this is 2 times what?
3x plus 4.
Yeah. Is all factoring is multiplication in reverse, in case you haven't gathered that. In other words, what we're doing is this term here was created by multiplying 2 times 3x plus 4. Let's factor a quadratic. Now, first of all, tell me why I can't use greatest common factor here.
Because there's x's.
Well, there's x's in 2 of the terms, and there's no x in the third term. In other words, this is the key right here. If you have a constant term, then it's very unlikely that you're going to find a greatest common factor, right? Because certainly x doesn't divide into 25, and 25 or 5 doesn't divide into 1. In other words, as long as that's a 1, and that's a number without an x, then it's very unlikely we're going to factor this by greatest common factor. However, it is the product of 2 linear factors. First step,
X and X.
second step,
Plus and plus.
third step. Verbalize the third step.
So you can do 5 and 5, and that would plus to 10. So yes, 5 and 5.
Okay, verbalize it for me.
What does that mean?
It means that what we're looking for are factors of 25 that add to the number 10.
Well, that would be 5 and 5. See,
Yeah, no, you got the right answer. I just wanted to know if you could verbalize it, because once you get to a point where you can verbalize it, you won't forget it, and you'll have it locked in your memory. So being able to verbalize that last step is important. Okay, and difference of perfect squares might be something like that. In other words, that's a perfect square. That's a perfect square. They're being subtracted, so it's the difference of perfect squares. How does that factor?
Oh, wouldn't you still do the x and x?
Uh-huh.
And then minus 32 on each side?
It's the square root, not divided by 2. I notice that that's a mistake you make frequently. In other words, what we're looking for right here is the square root of that number. What's the square root of 64?
8.
There you go. Notice that that's not 32. 32 would be 64 divided by 2. So there's a huge difference between taking the square root of something and dividing it by 2. What's the other term?
That'd also be 8.
Plus 8. It's always the conjugate. It's always the conjugate. In other words, you just take this term, change the minus to a plus, and you got your second term.
Okay.
Okay? All right. Now, I'm going to give you some problems, and you tell me whether it's greatest common factor, or quadratic factoring, or difference of perfect squares.
That would be, what's the first one that we did?
Greatest common factor. So what would it be? What would the greatest common factor be?
X.
And what would be the other part?
Then it would be 3x minus x, right?
Okay, now the moment I write that there, you should be multiplying those two together to make sure you get this. Do you?
No.
Okay, so that's not right. What has to go here such that when I multiply it by x, it's equal to x cubed?
2x?
Well, what would that be equal to?
4x.
No, that would be 2x squared. Remember, when you're multiplying variables, you add the exponents. How about x squared? Notice that if I multiply x times x squared, well, there's a 1 here. I add the exponents, I get x cubed. Okay? So, that's the first term. What's the next term? Say it. You were going to say it?
I was going to say 1.
That's it. What's x times 1? X. Okay? In other words, if I multiply this back together again, I multiply that times that, which is x cubed, and I multiply x times minus 1, which is minus x. That is what I started with. And that's the key on these factorings. Remember, factoring is just doing something in reverse. Now, is that fully factored? By that I mean, can I factor it more? Can I factor the x squared minus 1?
Since you asked, I'm going to say yes, but...
Very smart, very smart.
Oh, yeah, you can.
What is it?
So it's x on both sides. And then it's minus and plus, right?
Yes.
Yep.
In other words, that expression is now fully factored. I factored it down as far as it can go. If I were to multiply these three things back together again, I would get what I started with. So there were two steps in this one. There was greatest common factor, and then there was difference of perfect squares. I know you know the first step. Second step?
Minus and plus.
Verbalize the third step.
So you would take 10 and get what times to 10.
That means factors of 10.
So like 1 and 10, 2 and 5.
That have to do what?
Equal to 3x.
Not equal. Add or subtract?
Subtract to x. Right.
Not to x, but to the coefficient that's in front of x. So what we want is factors of 10 that subtract to the number 3. What factors are those?
5 and 2.
Which goes where? In other words, what's step 4?
The 5 goes on the plus and the 2 goes on the minus.
Always remember the bigger factor goes with the sign of the middle term. So the 5 has to go with the minus. And the 2 has to go there. Now, how can I tell if I've factored it properly?
You can add those all back together.
Okay. Is there a simpler way? In other words, when you said add them, you meant multiply them. In other words, if I multiply these all back together, I get x squared plus 2x minus 5x minus 10. When I simplify that, I get x squared minus 3x minus 10. That is what I started with. So that's the real way to check. But is there a shortcut?
I'm going to say yes.
Once again, because I said so. What is the shortcut?
Isn't it to...
Double smiley face. Remember that term. Double smiley face. What's double smiley face mean?
Like every
means
foil.
The inside and the outside. Remember that what they teach is FOIL, okay? Well, we don't really need to check the F part or the L part. What we need to check are those two. And how you get those two are by multiplying the outsides together and the insides together, adding them together, and that produces your middle term. So what's the insides multiplied?
The insides multiply to minus 5x.
The outside?
And the outside is 2x.
Add them together.
Then you get 3x.
Minus 3x.
Or minus 3x.
Minus is important. We wouldn't have wanted to get plus 3x. If we'd have gotten plus 3x, then I need to switch these two numbers. I would need to put the 5 with the other sign and the 2 with the negative. So doing that final check is really important because the middle term is the only term anybody ever misses. Okay? You're not going to get this term wrong, and you're not going to get this term wrong because you verbalized it. You know you want factors of 10. So we're never going to get those wrong. But the term that always people might get wrong is that middle term. Next step. Verbalize the last step.
So that would be 1. So 20. Oh,
Factors of 20.
20 and 1.
Hold on. What rule are we looking for? Factors of 20 that do what?
Minus 2, 1.
There you go. So let's list our factors of 20.
And then 2 and 10. But that can't be right. Then comes 5 and 4. And that would equal 1.
That would subtract to 1. So that's our answer. Where does the 5 go?
The 5 goes on the first one, and 4 goes on the plus.
Let's check it.
Oh, check it.
What's that?
So it would be minus 5x, and then
what's that?
4x.
Add them together.
Then it would be minus 1x, or just minus x.
Yeah, and that is the middle term, so that means we've done it right. Okay, good. You're getting good at those.
Yay.
Now, let's see if I can trip you up.
Wow, thanks.
Well, you're doing too good on the easy ones. I got to make them harder.
Oh my gosh. What did you do?
Well, what's this called? If you recognize as to what it's called, it won't be a hard problem.
Finding.
This is the third type of factoring.
Least common factor, or greatest common factor?
That's the first kind. Third kind is difference of what?
Perfect squares.
Okay, is this a perfect square?
Yes.
Is this a perfect square?
Hmm?
Okay, then we've got a difference of perfect squares problem. How does it factor?
Oh, I kind of forgot how to do these.
Take the square root of that.
6.
No.
Or 4.
Okay, for what?
4x cubed.
Not x cubed. If I square that, I'm going to end up with x to the 6th.
Oh, what is that? How do you say the 4?
You do it by squaring 4x squared. In other words, if I have 4x squared times 4x squared, multiply the two numbers, x squared times x squared, I add the exponents. So I get that.
Oh.
So it's doing the reverse of this. In other words, when you go to find the square root of this part of it, well, you take the square root of 16, but then you got to take the square root of x to the 4th, which is x squared. It's the second part. It's the square root of 36.
6.
It's the square root of y to the 4th.
Y cubed, or squared.
Okay. Now you don't have to do any work for the second half of this, right? What's the second part?
I have no clue.
It's the same as the first part, only opposite sign.
Oh, right.
4x squared plus 6y squared. That's why I said you don't need to do any work. In other words, you don't need to go back and redo square roots of this thing. That's the beauty of difference of perfect squares, is that the second part is very easy. Is all you have to be able to do is take the square root of that and the square root of that, and you essentially have your answer. All right, let me think here. Let's try a little harder one. may have to think for a second here. Hold on. Now, this is not a elementary quadratic to factor. This is what I call the second level. These are harder. Okay? What's the first step? The first step is still to break that up. Well, what two things multiplied together will give you 2x squared?
1x.
And?
X.
Well, does that multiply together to give me 2x squared? No, it gives me 1x squared. So, I need to put a 2 in front, like that.
Wait, but wouldn't that get you, 4?
No, if I have 2x times x, well, that's 2x, add the exponents, 2x squared. Alright. So, the first step is still the same. The first step is to break this up. However you have to. I mean, sometimes it can be very complicated, but I'm going to guess that you're not going to get anything more complicated than this for a while. Second step is still the same. What's the second step?
Plus and plus.
Now, here's where it gets different. You can no longer say the third step is factors of 5 that do anything. Doesn't work that way. Once you get beyond the elementary quadratics, in other words, any quadratic that has a 1 here, then those rules kind of go out the window for the third step. But all you have to do is use a little trial and error. Give me the factors of 5.
1 and 5. And yeah, that's it.
That's it. So, to find the answer, we don't really have to do a lot of work. I can try 5 there and 1 there. And if that doesn't work, got to be the other way around. Does this work? And use your final test. Use your double smiley face to see if this works. What's that equal to? What's that equal to?
So that would be plus 5x, and that would be 3x plus
2x. Remember, anything multiplied by 1 is the same thing. So when I multiply 2x by 1, I still have 2x. Add them together, what do you get?
You get 12.
No, you don't. 5 and 2 do not add to 12.
Right.
It adds to 7, which means that's not the correct answer.
So it's got to be the other way around.
It's got to be the other way around. Let's switch the 1 and the 5. 1 goes here, the 5 goes there. I made a mistake, incidentally. When I was setting this up, I meant to put an 11 there. Now, it doesn't really matter. So now check, what's the insides multiplied to?
Multiplies to 1x, or x.
And the outside?
Oh man, 10x.
Add them together?
11x.
Aha, that's the answer. So, this last step is extremely important when you're doing these kind of quadratics. In other words, anything that has a number other than 1 is going to be a lot more difficult and always requires you to do the double smiley face test. Okay? So, let me give you another one. Hold on a moment. I got to think, because I have to figure out what the product's going to be before I can give it to you. I mean, it's hard to do these in reverse. Let's see. Okay, this must have been what I was thinking about last time. First step.
The 2x and then x on the other side?
Yeah, it's always that. In other words, that's the same as this. Doesn't matter. Okay? As long as the two numbers multiply together to give you this, that's all that matters. Now, what does matter is I would not want to do this. Even though 1 times 2x squared gives you this, that's never the way to factor. You always split up your x's. Okay?
Okay.
So it's always going to start out like that, as long as this number is a 2. Now, I think you can begin to see that as I make this number bigger, I'm going to produce a lot more possible ways to split it up. If this was a 4x squared, I could split it up as 2x times 2x, or I could split it up as 4x times x.
Or if you had like a 1, then you could do 1x, or you could just do xx, right?
It's always xx if it's a 1.
Okay.
That's why I call those the elementary or level 1 ones. Okay, what's the next step?
Then it'd be plus plus.
And
Same.
finally, list factors of 10 for me, starting with that.
1 and 10, 2 and 5.
Let's do it methodically, like this. Okay. I mean, I could have done it 1 and 10 and 2 and 5. That's fine. Is that it?
I feel like there's one more.
Yeah, I kind of feel like there's one more too, but there isn't.
Oh, okay.
Okay? I mean, but it's always good to be checking. You want to find all of them. Now, is there any rule that I can say?
That you can what?
Can I state any rule? Can I say factors of 10 that do anything? No, because this is a level 2 quadratic. You can't do that with level 2 quadratics. And it's not level 2 because this number is 2. It's level 2 because this number is not 1. So, I've got to try these combinations. Now, when you're doing trial and error, always start with the two factors that are closest together. Which two factors are closest together?
The 5 and 2.
Okay. So let's try 5 here and 2 there. Does that work?
Let me see.
See if you can do it in your head without drawing the smiley faces. Or without me drawing them.
Yeah, that's what I'm trying to do right now.
Okay.
Nope, that doesn't work.
Okay, let me switch them. Does that work?
Nope.
What's the insides multiplied to?
The insides multiply to 2 and x, and the outs multiply to multiply. So that 10. So that would work.
Yes, it does work.
Man, dang.
Now, what would we do if it didn't work?
Then go to the 10 and 1 and try
You
that.
got it. You got it. Let me see if I can come up with... If the problem was this, and we had tried the 2 and the 5, and the 5 and the 2, obviously neither one of them produces a plus 21 in the middle. So our next step is to try the 10 and the 1. Where should I put the 10?
I'm going to say on the outside.
Yeah, because I know I've got to get up to 21. I need the 10 multiplying a bigger number.
So that would work.
That would work. That gives you 1x, 20x. Add them together, you get 21x.
Yeah.
Now, what happens if this is a 9 and nothing works?
I have no clue.
Right, you haven't been taught that yet. There's something called the quadratic formula. Have you ever heard of it? Let me write it and see if you recognize it. It's very complicated. Most people shudder when they even think of this. You ever seen that?
No, and I wish I hadn't.
Okay. We won't go there then. But that's what you do. In other words, not all quadratics are going to factor nicely. This one does not. There's no way I can factor this no matter what I try. I can try all combinations. Factors of 9 are either 9 and 1 or 3 and 3, and neither one of them produce that as a middle term. So you should at least know that there are quadratics that cannot be factored. And when you run into one of them, you do have an alternative. It's called the quadratic formula, and it's the thing I just wrote. But that's usually not taught, at least until mid-first year algebra. So I'm not going to go there. But you should know that there is a solution for this. It just doesn't involve whole numbers. In other words, I'm not going to have a nice round number there. I'm going to end up with square root of some number when I use the quadratic formula. Okay.
I think it's time to go.
Ah, you're right. Sorry. Thank you for calling that. A good session. You did good today, Garrett. Really good.
Well, thanks.
Yeah, no, you're picking up this stuff, I believe. And I will talk to you next time. Okay. All right, bye-bye.